Welcome my dear learners for this course on control engineering. In this module 2 we will discussing on block diagram reduction and signal flow graph. Today we are heading for the final lecture on block diagram reduction. So let us continue our discussion. The problem number 6 of our discussion on block diagram reduction states that determine the transfer function C of s by R of s for the block diagram shown in figure if G1 is equal to G2 is equal to 1, G3 is equal to G4 is equal to 2 and H1 is equal to H2 is equal to 1 and H3 is equal to 2. Now as I said in step 1, let us split all the combined summing points and takeoff points and write it properly so that we can clearly visualize how to proceed with the given problem. So therefore, if I move for the solution of problem number 6, in step 1 I will rewrite the problem by splitting all combined summing points and takeoff points. That is, in step 1 we have R of s, we have a summing point with negative feedback, we have G1 and we have a takeoff before G1 to G4, which means G1 and G4 are in parallel. Next we have a summing point with plus with a feedback of minus to G2, and if you carefully observe we have two feedbacks coming to the summing point, two paths coming to this summing point. One is the forward path G4, another one is the feedback H3. So therefore I will write it twice, splitting it up I will write it twice. If I write it twice, so however you want you can write, because interchanging of the positions of summing point will not make any difference. That is our first rule in block diagram reduction. Plus, and then we have minus H3 to G3. And a careful observation will reveals that we have three feedbacks going from the same point. So therefore connect all these three to the main line. So write it separately. I will get three takeoffs. So one for H3, one for H2, and one for H1. And finally we have the output C of s. So now directly we know that this is the loop. So therefore close this loop, because we have one forward path, one backward path having only one block each, and also we have one takeoff, one summing point. So therefore close this loop, that is G of s by 1 plus G of s H of s. Because the feedback is negative, I should use positive in the denominator. So if I solve for that, I will get in step 2 the block diagram reduced to R of s. We have the summing point with a negative feedback of H1. We have a takeoff for G4, and then we have G1. Again we have a summing point with plus minus. We have G2, we have a summing point again, both are positive. So if I close this, I will get the value as G of s is G3 divided by 1 plus G3 H3, and we have two feedbacks H2 and H1. We have the output C of s. Now in order to move further, either I can shift this summing point behind G2 and solve, or I can shift this summing point in front of G2 and solve. We know that if I shift the summing point behind a block, I should add inverse of the block value to the incoming path, whereas if I shift the summing point in front of the block, I should add the block value itself to the incoming path. So therefore, in order to avoid the inversion, let me shift this one in front of G2 and interchange the positions. If I shift this in front of G2 and interchange the position of the summing point, that is, I will take this first and the shifted one next. Then step 3 will yields us, we have R of S summing point, a feedback coming to it, a takeoff to G4, we have G1, G2, so I shifted and interchanged the positions of the summing point. So since I have shifted, now I should write for this as adding G2. So adding G2, we already have H2. So now I left out with G3 by 1 plus G3 H3. So now I think we have arrived for the solution. Just what I done is that I shifted the summing point in front of G2, hence I should add G2 to this feedback line H2. I have done that and I have interchanged the positions. Shifted and then I interchange the positions, because interchanging of summing points will not make any difference. That is our first rule. So I have done that. So now this is completely solved. This is also completely solved. Correct. So these two are in series. So this is G1 G2. For G1 G2, G4 is parallel. So hence the loop answer is G1 G2 plus G4. So therefore in step 4 I will get the solution as R of S. We have summing point, feedback is minus H1. This block will be reduced to G1 G2 plus G4. G1 G2 plus G4, and this is G of S, this is H of S. So therefore G of S divided by 1 plus G of S into H of S. If I do, what I will get? G of S is G3 by 1 plus G3 H3 divided by, since we have negative feedback, I should use 1 plus, again G of S is G3 by 1 plus G3 H3 into H of S value is G2 H2. If I take LCM and cancel off the denominator, I will get the value as G3 divided by 1 plus G3 H3, 1 plus G3 H3 plus G2 G3 H2 plus G2 G3 H2. So this is what I will get. So we have only one feedback, that is H1, and we have C of S. So these two are in series, so therefore this is nothing but the product. Hence in step 5 we got the canonical form of the. Now moving for step 5, so final canonical form will be R of S minus H1. So we have G1 G2 G3, G1 G2 G3 plus G3 G4 divided by 1 plus G3 H3 plus G2 G3 H2 plus G2 G3 H2. We have the takeoff and the output. So this is the canonical form of the given problem number 6. That is, forward path has only one block, feedback path has only one block. We have one summing point and one takeoff point. Now I can find what is the transfer function. Therefore, the transfer function C of S by R of S is equal to G of S G1 G2 G3 plus G3 G4 divided by 1 plus G3 H3 plus G2 G3 H2. G of S divided by 1 plus again G of S, that is G1 G2 G3 plus G3 G4 divided by 1 plus G3 H3 plus G2 G3 H2 into H of S is H1. So therefore, if I take LCM and simplify, I will get G1 G2 G3 plus G3 G4 divided by 1 plus G3 H3 plus G2 G3 H2 whole divided by 1 plus G3 H3 plus G2 G3 H2 plus H1 should get multiplied. So therefore, I will get G1 G2 G3 H1 plus G3 G4 H1 whole divided by 1 plus G3 H3 plus G2 G3 H2. So these two will get cancelled. Hence, the transfer function is G1 G2 G3 plus G3 G4 whole divided by 1 plus G3 H3 plus G2 G3 H2 plus G1 G2 G3 H1 plus G3 G4 H1 H1. So this is the transfer function what we got. Now we has given the values of these transfer function of minor blocks G1 G2 G3 G4 etc. Substitute and find what is the value of transfer function. So G1 value is 1, G2 value is 1, G3 value is 2 plus G3 value is 2, G4 value is also 2. This is divided by 1 plus G3 H3, G3 value is 2, H3 value is 2 plus G2 value is 1, G3 value is 2, H2 value is 1 plus G1 value is 1, G2 value is 1, G3 value is 2, H1 value is 1 plus G3 value is 2, G4 value is 2, H1 value is 1. So if I solve, I will get 2 plus 4 is 6 divided by 1 plus 4, 4 plus 1 is 5, 5 plus 2 is 7, 7 plus 2 is 9, 7 plus 2 is 9, 9 plus 4, 9 plus 4 is 13. So the answer is 6 by 13. So therefore transfer function C of S by R of S is 6 by 13. So this is the value of the transfer function. So this is how you should solve. So this is the solution for problem number 6. Let me pause this video for a while so that you people can copy it down. Later we will solve the final problem, that is problem number 7. Now moving ahead for the final problem, the problem number 7 states that reduce the given block diagram into canonical form and determine the closed loop transfer function, also represent in open loop form. So this is the problem we have. This is a straightforward problem. So if you have thoroughly followed all the 6 problems, this problem is the most easiest one among all the 7 which we have discussed so far. So it is a direct problem. He himself has been given in the clear cut form. There is no combined summing point or takeoff points. So directly we can solve this problem. If you clearly observe, this is an loop. We have one forward path, one backward path, each have only one block each. If nothing is there, it means that it is a unity feedback. We know that. So therefore this can be closed, and these 3 are in parallel because all the 3 are forward paths. So these 3 are in parallel, so therefore I should add all these 3. Then these 4 will be in series, so multiply those 4 and finally we will get it in canonical form. So if I do that, I will get the solution for problem number 7 as, in step 1 itself I can solve this problem. So first we have theta 1 of s as the input, plus we have a summing point with negative sign. We have the block value as 10. Since this is a loop, we know that the solution is g of s divided by, since the feedback is negative, I should use positive, 1 plus g of s into h of s is 1, because if you don't have anything, it means that the block value is unity. So this is the value of the minor loop. Next we have 1 by s plus 2 as the block value, and next it is clear that all the 3 are parallel to each other, hence the solution is 1 by s plus 3 plus 1 by s plus 2. And we have the output as 2. So is this the canonical form? No, because canonical form has one forward path, one backward path, correct, but the number of blocks in the forward path and feedback path should be 1. How many blocks we have? Here we have 4 blocks in the forward path. So therefore this is not the canonical form. The canonical form is when we multiply all these 4 and write in one block. So therefore, to get the canonical form, let me multiply and write. So if I multiply and write, how much I will get? That is, we have 10 into 1 by s into s plus 1 by s plus 1 by s into 1 by s plus 2 into, throughout if you take s into s plus 3 as LCM, I will get s plus 3 plus 2s of s plus 3 divided by s into s plus 3. So this is what I have. So if I solve this, I will get the solution as ten times s plus s is 2s, 2s plus 3 plus 2s square plus 3 2s are 6s divided by s of s plus 1, s plus 2, s plus 3. So this is what we have. Let me solve it further. If I solve it further, we will get 20s square plus 6 plus 2 is 8, 80s plus 30 divided by s square plus s square plus s get multiplied with s square plus 3s plus 2s is 5s, 5s plus 3 2s are 6. Now that should be get multiplied. So therefore the canonical form is of the given problem will be theta 1 of s plus minus, we have the forward path block value as 20s square plus 80s plus 30 whole divided by s power 4 plus 5s cube plus 6s square plus s cube plus 5s square plus 6s. So put together I will get 6s cube plus 6s cube plus 5 plus 6, 5 plus 6 is 11, 11s square plus 6s. So we have the feedback as 2. Theta naught of s. So this is what he has asked. Reduce the given block diagram into its canonical form. We have reduced it into canonical form. Now I can find the transfer function. So therefore transfer function will be that is theta naught of s by theta 1 of s, which is equal to g of s by 1 plus g of s into h of s. H of s is 2. So therefore if I write and take this as LCM and cancel off, I can write it directly 20s square plus 80s plus 30 divided by 1 plus, when I take LCM this will get multiplied to 1. So therefore it is s power 4 plus 6s cube plus 11s square plus 6s plus this multiplied by 2, that is 40s square plus 160s plus 60. So if I simplify further, it is 51s square plus 166s plus 60. Correct? It will be 51s square plus 166s plus 60. 51 166, that is 51s square plus 166s plus 60. So this is what I will get if I solve for g of s divided by 1 plus g of s into h of s. So this is g of s divided by 1 plus again g of s into h of s is 2. Take this as LCM and simplify. This is what you are going to get. So this is the solution for the problem number 7. Finally he states also represent it in open loop form. So the open loop form is, so open loop form should not contain feedback. So remove feedback, enter the transfer function. That is, we have theta 1 of s, open loop form of the given problem, which does not have any feedback. So this is the complete solution for problem number 7. So this completes our discussion on block diagram reduction. In our next lecture, I will take up, or I will begin the new topic, that is signal flow graphs. That's all from this lecture. Thank you all.